Hello, everyone, and welcome to Snowflake Unboxed. I'm Bharat. I'm currently a software engineer intern at Snowflake, and I'm excited to take you on this journey into Snowflake's internal architecture. Many people know Snowflake as one of the leading cloud data warehousing solutions, but fewer know what happens behind the scenes to make it such a powerful platform. This series is all about unpacking Snowflake's internal workings, making these complex systems accessible to everyone, from engineers to architects to anyone who's interested in how cloud data warehousing operates. Now, you might be wondering why this topic? Well, in the field of cloud data platforms, Snowflake has made a big impact because of its elasticity, scalability, and unique approach to data management. Despite its popularity, I noticed a gap in the educational content that explains the technology behind it. If you search online, you'll find plenty of tutorials on making use of Snowflake, how to query data, how to set up the databases, how to connect to Snowflake with other tools, and so on, so on. But then when it comes to understanding how Snowflake works under the hood, things get a bit sparse. Official documentation and white papers are out there, but they're so dense and packed with technical terms that it's often very hard for beginners to digest and understand it. And even for intermediate learners, it's not straightforward. So, with this series, we're aiming to bridge that gap. Each chapter is designed to break down specific part of Snowflake's architecture and process. By the end, my goal is to provide you with a solid understanding of how Snowflake's components interact, making Snowflake's technology more accessible and application to your work or learning journey. We'll have five main chapters. Each chapter will have its own playlist. So this way you can easily find specific topics or revisit them as you need. Whether you're completely new to Snowflake or if you're already using it but want a deeper understanding of its internals, this series is for you. I'll aim to keep things straightforward, breaking down complex concepts into bite-sized explanations. So let's jump into the first chapter, Snowflake architecture. Starting off with the overview, in this chapter, we're going to build a high level understanding of Snowflake's internal architecture. Now, Snowflake isn't just a typical database or a data warehouse, it's a platform designed from ground up for the cloud, taking full advantage of the cloud capabilities. So, this approach is unique compared to traditional data warehouses, which were often designed with on-premise servers in mind and later adapted to for the cloud. Snowflake's architecture was designed specifically to leverage the cloud infrastructure, and that's one reason it can offer the level of performance, scalability, and elasticity that it does. Snowflake's architecture can be thought of as a multi-layered system. At the core, we have three main layers: the storage layer, the compute layer, and the cloud service layer. Each of these has a unique role and is designed to perform specific tasks independently. This is a crucial design choice because it allows Snowflake to scale each layer independently based on the user needs. For example, if you need more storage but don't necessarily need more compute power, then you can scale storage independently without affecting the other layers. This separation makes it possible to run multiple workloads without interference, a feature that's particularly attractive for huge organizations which have intense data processing needs. We'll start by looking at cloud data warehousing in general and how Snowflake design is different from the existing ones. The traditional data warehouses were more monolithic, meaning everything was interconnected, tightly coupled. This tight coupling often led to bottlenecks. Snowflake, by contrast, separates its components, which helps maintaining loads efficiently and maintaining high performance even under heavy demand. This separation is one of the reasons Snowflake can offer its famous near infinite scalability. In this chapter, we'll specifically discuss this sigmoid paper that was published by Snowflake in 2016, discussing all of its internal workings. In the next video, we'll dive into each of these layers: storage, compute, cloud services, to understand how they work individually and with each other. This layered art architecture is what gives Snowflake the ability to efficiently manage massive amounts of data across many users. Understanding this will set a solid foundation as we continue exploring Snowflake's unique features and capabilities. In the next chapter, we'll dive into the core layers of Snowflake. There are storage layer, compute layer, and cloud services layer. Each of these layers plays a distinct role, and together they make Snowflake the high performance platform it's known to be. So let's start off with the storage layer. Storage layer in Snowflake is designed to handle vast amounts of data. Unlike traditional storage solutions, Snowflake stores the data in a compressed, optimized format called micropartitions. These micropartitions are the fundamental component of Snowflake's architecture. They help with efficient data retrieval, ensuring that only relevant data is loaded when you run a query. This is a huge improvement over the traditional databases where often you'll need to load a large portion of data to retrieve even a small amount of rows from that. Snowflake storage layer is what makes it possible to scale horizontally, meaning that you can add as much data as you need without affecting the performance. This is why Snowflake is suitable for companies with enormous data volumes. Moving on to the compute layer, this is where the processing happens. In Snowflake, the compute resources are handled by what's called virtual warehouses. These are independent compute clusters that can be scaled up or down based on your workload. Well, virtual warehouses enable Snowflake to handle multiple users and queries simultaneously without interfering with each other. For example, if a company has a team doing heavy data analysis, they can scale up a virtual warehouse just for that team without impacting any other teams. So, this ability to isolate workloads and dynamically adjust resources is the key to Snowflake's high performance promise. The final layer is the cloud services layer. This layer handles everything from managing the metadata to enforcing security protocols and optimizing queries and everything you can think of. The metadata management is especially important because it's key. It keeps track of where the data is stored and optimizes the access to it. Security is another crucial part of this layer, as Snowflake must comply with various industry standards and ensure that the user's data remains secure. So, in this chapter, in the playlist for this chapter, we'll go deeper into each of these layers, learning not only how they work, but how they work with each other. By understanding these layers individually, you'll gain a clear picture of why Snowflake is able to offer fast, reliable, and scalable services like it does. With this understanding, you'll be better equipped to appreciate the complexity behind the Snowflake's cloud native design. In the next chapter, this is a super interesting chapter. We will go through the life of a query in Snowflake, from the submission of a query from the user all the way till he or she gets the result. Every query in Snowflake goes through multiple stages, each of which plays a crucial role in delivering fast, optimized results. Let's break down each stage. When a query is submitted in Snowflake, the first step is query parsing. So this is where Snowflake reads the query, checks for syntax errors, and checks for what data will be required for the query to actually be executed. Once the query is understood by the system, it moves on to optimization stage where one of the key reasons Snowflake performs so well. Optimization involves making choices about what's the best way to execute this query based on the available data and resources. It's like mapping out the shortest route before a road trip. Snowflake's optimizer looks at all possible execution paths and picks the one that's most efficient. After optimization, we move on to execution planning. And in this stage, Snowflake allocates resources for the query. This means deciding which virtual warehouse will handle the query and setting up any required data access. Snowflake can split large queries into smaller tasks, allowing multiple parts of the query to run simultaneously across multiple warehouses. Finally, we reach the execution and retrieval stage, and here's where Snowflake retrieves the data, processes the data as needed, and compiles the result. Snowflake's architecture allows it to manage all these steps efficiently, delivering quick response even from complex queries. In this chapter, we'll take a detailed look at each of these stages and how they work together and provide an optimal experience for the user. The next chapter will take a look at ingesting data into Snowflake as this is one of the most crucial parts of using the platform effectively. Snowflake offers several ways to bring in data, each with its own use case. In this section, we'll explore the main techniques for data ingestion and how to choose the best method for different scenarios. The first technique is bulk loading, typically done with the copy command. This method is used for large scale data workloads like bringing in data from a CSV file or another database altogether and so on. The copy command is efficient and works well for a periodic batch uploads, making it ideal for historical data and large databases that really don't need real-time updates. For real-time data needs, Snowflake offers Snowpipe. Snowpipe enables continuous ingestion of data as it arrives. It's often used for streaming data from IoT devices and applications and other sources where data is constantly being updated. Snowpipe is designed to ingest data in real time so you can start analyzing it immediately after it arrives in Snowflake. The newest addition to Snowflake's data ingestion toolkit is Snowpipe Streaming. Snowpipe Streaming is built for ultra low latency data ingestion. It's particularly useful for scenarios where milliseconds matter, such as financial transactions or live application monitoring, and so on. By understanding these different ingestion techniques, you'll be able to choose what's the right one based on your data needs. In this chapter, we'll explore each technique in detail and discuss the best practices for using them effectively within your Snowflake environment. Our final chapter will explore Foundation DB and the metadata management in Snowflake. Foundation DB is basically a key value store at Snowflake to store and manage metadata. Metadata is the information that describes other data, like where data is located, its structure, and how it should be accessed. In Snowflake, metadata is essential because it allows platform to quickly identify where specific data is stored and optimize the data retrieval and ensure consistency across various operations. Foundation DB plays a crucial role in Snowflake's stateless architecture. Unlike traditional systems where metadata is tightly coupled with the data itself, Snowflake keeps the metadata uh, separate. This stateless approach allows Snowflake to scale horizontally and handle high volumes of metadata without slowing down the query performance. Metadata management in Snowflake is designed to support scalability and reliability. By storing the metadata in Foundation DB, Snowflake ensures that all metadata changes are consistent and can be replicated across various regions for high availability. In this chapter, we'll break down Foundation DB's role in managing the metadata in Snowflake. We'll explore how Snowflake ensures metadata consistency, scalability, and security. By understanding metadata management, you'll gain insight into how Snowflake maintains a balance between high availability and performance, which is a crucial part of why Snowflake is a trusted data warehousing solution in the cloud. Thank you so much for tuning in to this introductory video on Snowflake Unboxed. I am excited to bring you along this deep dive into Snowflake's architecture and to uncover what makes it such a powerful and unique cloud data warehousing platform. As we go through each chapter, my goal is to make Snowflake internal workings as accessible as possible, breaking down complex topics into understandable bite-sized explanations. Each playlist will guide you through a specific aspect, from architecture itself to how Snowflake processes queries, manages metadata, and handles data ingestion. If you've ever wondered what's behind the impressive performance, scalability, and elasticity of Snowflake, this series is here to answer all of those questions. Once again, thank you so much for watching, and welcome to Snowflake Unboxed, your guide to understanding Snowflake from inside out. I look forward to sharing this journey with you, and I'll see you in the first chapter.